like what I'm going to go over today that's on the final. So, all right, so let me explain a little bit about what this is. This will be something that you'll see in Calc 3 and beyond quite a bit. So a parametric equation, we generally have this kind of structure like this. Now what you're doing with this, and it'll make a lot more sense when I start doing examples, is it turns out that if you have some sort of a function, and that function could be anything, like f of x equals even a parabola or something like that, well, you can break it down into two functions. We call that parameterizing, where one function gives the x value. So you're getting a set of points, but this x of t is a function within itself that gives x values, and then y equals g of t is going to give the y values like that. So the idea is we split this thing up into two functions, one that generates x's, one that generates y's, and then we can generate all those points, okay? And then the parameter is generally what we're going to use most of the time is t as our parameter, okay? That's a variable like that, okay? So again, what we do on this is this parameter t breaks it up into two functions, one that gives x and one that gives y. This will make a lot more sense once I go through and show you this example down here. Okay, so here's an example, and then I'll talk a little bit about what the positive orientation means as I go through some of these examples. This is one that I've already done, so this would be an example of a function that's been parameterized. And notice that we have an equation for x and an equation for y. Now I'm going to just sort of show you what is going on this problem. So let's start with t. T is going to be defined on this problem to go from 0 to 1. That's your parameter. And one thing I want you to write down on this is if t is equal to 0, let's just work a couple of these out. So we would have 4 cosine of 2 pi times 0. So that's going to be 4 cosine of 0. Well, we know the cosine of 0 is 1, so that's going to give 4. So see, that gives an x value right there. That is a function that's generating an x value. Okay, then we'll go to y. Well, y is 4 sine of 2 pi times 0. So that's 4 sine 0. So that's 4 times 0, that's equal to 0. So see what I'm doing on this, and I'm not going to do all these, but the idea is t is some parameter, and it generates x and y values like that. Okay, this is called parameterizing. And if you graphed all these points, you would do the same thing. You would just go on, and I'm not going to do the details of this, but if you went through and let t be equal 1/8, like that, and crunched out the details, it'd just be unit circle stuff, I'm confident you'd be able to do that okay. So you get another point square root of 2 root 2, comma 2 root 2. Okay, so then what we do is if you plot these points, it kind of goes like this. This is the first point, is 4, 0. The second point is this. And you'll notice on this, one thing I did is I put little arrows on this. This is generating a circle. And that's called the positive orientation. So you start with when t is 0, that generates your first point, and then you're just going around this way, and if you're going in the order that t is, that's called the positive orientation. Okay, does that make any sense? Okay, so what we do is we're just going to get sort of barely introduced to this concept here, and so we're going to do a couple of things where we do some graphing and then identify the positive orientation on the next page, okay? All right, so this is kind of I think will help you understand what's going on in the problem. Okay, what I've done on this one is I've given you the parameter is t. Again, we call that the parameter. T is kind of the standard thing. And if you guys take physics, you'll do this a lot in physics too, quite a bit. Okay, so what we have is we have two equations. You have this one generates x, this one generates y, okay? And what we're going to do on this is we're going to go ahead and just start with t is -4, and then we're just going to go up by 1s. You can go up by anything you want to. The more increments you break the t's up, the more accurate your graph's going to be, but we're just going to go by one. So let's go ahead and fill this out like this. Then we'll go all the way up to 4 like this, okay? Now what I'm going to do on this is we're going to fill out a couple of these. So let's find the x's. So x is equal to t squared plus 2. Let's go ahead and just do that real quick. And you can probably start doing this in your head after we do a couple of these. So what we're doing is x is t squared plus 2. So I'm just going to plug in those t's and calculate and number crunch, okay? So again, I'm going to plug in -4. Okay, then I'm going to plug in -3. Let's do the first two, and then once you get the hang of it, I'll just write down the rest so we don't have to spend a bunch of time on this. So this would be 16 plus 2 is 18. This would be 9 plus 2 is 11. So then we would have that. Okay, everybody see what I'm doing? Okay, so you're just going to do this over and over again. Now you can do this in your head. I'll do one more, and then I'm just going to write down the rest. -2 squared plus 2, that's 4 plus 2, so that's 6. And then you just keep going down. The rest of them I'm just going to fill in. So I've got 3, 2, 3, 6, 11, and 18. Okay? A real fast way to generate those is just to put that in your graphing calculator. And I'll show you how to do this in a minute here on the graphing calculator. Okay, any questions so far? That should be real easy. Okay, and then the next thing we're going to do is we have y is equal to 4t. So again, we just do 4 times whatever t is. And this is easy enough. You can probably do this in your head. So let me just do the first couple. So we have -4 is our parameter, then -3, then -2. So if you work out the details on that, that's going to be -16 here, -12, -8, and so forth, like that. Okay? All right, and then I'm just going to fill in the rest. You can fill in the rest. -4, 0, 4, 8, 12, 16, like that. All right, so everybody see what I'm doing there? That should be a piece of cake compared to what we've done. So you're just doing arithmetic, and what we get, see, is we get points. So these things right here are points that we're going to plot. And we're going to plot them in order on this graph I gave you down below. And then you got to kind of do this positive orientation as you do that then, okay? All right, so you can go ahead and start plotting your points, okay? So, and we'll see kind of what we have to begin with here. So I'm going to start at 18, -16. This is really hard for me to see. So that's my first point. Then I have 11, -12. I got to zoom on this. Let me just look at my points from my notes here. Okay, now let's see. Then I got 11, -12. Okay, so that looks like that's down there, I think. Okay, 11, -12. 6, -8. Okay, and then 3, -4. And let's see, 2, 0. And then 3, 4. And then 6, 8. Okay, I think I'm okay. Then 11, 12. And finally 18, 16, like that. Okay, now that's what your points are. Now, what we're going to do now is we're just going to connect the dots, but we're going to connect this kind of with arrows. And this is a parabola is what it is. This is just the parameterized form of a parabola. So the other thing that you want to do on this, and this is important, this was your first point, this was your second point, and so forth. So just kind of put arrows that are showing what we call the positive orientation. So again, we're starting here, then we're going like that. So that gives you a graph of a parabola like that. That's all there is to that to start with then, okay? All right, does everybody understand what I've done so far? Yes or no? That should be like super easy, I would think, okay? You just haven't seen this idea of parameterization. Now, get your calculator out. I want to go ahead and show you how to do this on your calculator, okay? So, first thing that you want to do, you may have to make some notes on this because I didn't put this on your handout, is you want to press, and I'll kind of write down the keystrokes. You have a mode button, You want to press that mode button, and then you want to go to, you're probably on function mode. You want to go to where it says parametric, then you want to press enter. Okay, so you got to get that thing changed to parametric. Okay, you might want to make sure you're in radian mode. It doesn't matter on this problem because we're not talking about angles, but we'll probably do one in a minute that's got trig functions like that. Okay, so that's how you do that. Now, what we're going to do is when you press y equals, you're going to notice that everything's totally different now. Okay, you're going to get like a x of t and you're going to get a y of t like this. I need to change this thing too real quick because I was working on this thing for my trig class. So let's see. Let me get a line on here. So I think that'll probably be okay. All right, so now just type in x1t, just type in what we had. Now when you type your variable button, which is this right here, don't go looking for the t, just do that and the t will come out. Then you're going to do t squared and then plus 2. Okay, so you get that equation put in like that. Then you have 4t. So we have that. Whoops, need to clear that out. So I just go 4t like that. Okay, that's how you do that. Now your window's a little bit different on parametric equations. So let me show you how to do the window. So you just do your y equals like that. Whoops, come on, move over there. There we go. Okay, and go ahead and press your window button. So if you press your window button, okay, what we're going to do on this is we're going to look at the t. The t was given as -4 to 4. So what we're going to do is go -4 to 4 like this, just like that says. Now you can t-step that forever, whatever you want. We t-stepped by 1 here, so if you want to do 1, you can do that, okay? Or if the smaller you go, the more accurate it gets, but this is probably pretty good on this one. And then the x is just like the graph we did here. So let's go like 0 to 20. If you look at my x-axis, that went out to about 18. Then you can scale by 1 or you can scale by 5 or something like that. Then the y's we're going like, let's go -20 to 20 like this. So go -20 to 20 and then maybe a scale of 5 or something like that. Okay, then if you type graph, it should graph what I had there. Okay, so now everything's set up. You got your window. You type graph. Now what's doing is it's putting the same dots that we have there. If you did that t-step, like if you did this t-step and made it real small, you might want to try this. Like if you tried something like 0.01, okay, then all it's going to do now is it's just going to plot a whole bunch of points, so it's going to generate that parabola like that, okay? So that's how that works. This would be something that would be new to you. I don't think you've probably ever done this before with your calculator, but that's how you set up parametric equations, so you need to know how to do that, okay? All right, do you guys have any questions about how I set the calculator up? Is that working okay for everybody that brought their calculator? Okay, all right. So see, you want to know how to do this, and when you do your homework, the homework on this section is not very long, and you can save a lot of time by doing it this way, because I assume that you guys aren't going to have any trouble doing the arithmetic on this table of values, so you could also go second graph to get a table to come out. And see, when you're in parametric, see, it'll make that table for you. So we went through on that, and then t is incremented by 1. You can get those same values that we got by hand real fast on that, see, if you do that. So I'd recommend you learn how to use your calculator, okay? All right, any questions so far? Okay? All right, let's move to this next page. Now, this elimination of the parameter, let me explain what that is. So let's go ahead and write down what those two equations were. We really had x of t. I didn't write it that way. I just wrote x. That's t squared plus 2, like that. So we have t squared plus 2, and then we have y of t is equal to 4t like this. Okay, now you can leave off that y of t and x of t and just write x and y if you want to. So what we do is we try to eliminate the parameter. That means we get our equation with just y and x. And then you'll probably recognize the graph of its parabola. So there's different ways you can do this. The first thing I'm going to do is I'm going to take this equation and I'm going to solve it for t, because it's easy to solve for t. That's why. I could take the first equation and solve it for t, but then you'd have to square root and you'd get the same answer, but it's a little harder. So what I'm going to do is just divide both sides by 4 here, and that's going to give me t is equal to y over 4. Okay, now what I do is I take this thing. This is what t is, so that's going to plug in there into the other one. So you solve one equation for t and plug it into the other one. That's what you do most of the time. Some of these problems we're going to do, you have to do something a little bit different. So go ahead and write down the first equation, okay, which is x is equal to t squared plus 2. But again, what you're going to do is you're going to replace the t with what it is when we solved it like that, so that's y over 4 squared. So solve an equation for t, plug it in the other. That's usually the first thing to try. Okay, now if you get into like logarithms and trig functions, you got to take a different approach. Okay, so what you're going to have then is x equals y squared over 16, when you square that, plus 2. Now we're just going to solve that equation for y. Okay, so I'm just going to do this in my head. I would get x minus 2 is equal to y squared over 16, just subtracting 2 from both sides. Now what I'm going to do is multiply both sides by 16 to get rid of the fraction. Okay, so what I'd end up having is y squared is equal to 16 times x minus 2. Now you can multiply that out if you want to, but that's the equation in terms of x and y. Okay, now you guys may have kind of a limited background on what we call conic sections. You do a little bit of this in college algebra. But that's any time that your equation is quadratic in one variable, then it's a parabola. It could either be x squared and y, or it could be y squared and x. So if it's quadratic in y, that means that it orients itself around the y-axis. Now this is not a function, clearly. That violates the vertical line test, but it is a parabola. Okay? So that's what this is let's just say it's a parabola. And all we need to say on this is this opens around the x-axis. Okay, so that would be what that curve is, all right? So that's kind of the complete problem that you want to know how to do. This is typically a type of thing you see on the final exam. And it's real easy to do. What do you think? Okay, does that seem easy? Okay, all right, let's do a few more of these. I'm going to do several of these because there's different things that can happen on this then, okay? And what I'm going to do with this one is, again, let's just crunch out a couple of these and then just I'll just give you the rest of them here. You can do this on the calculator also. Okay, so let's see. Let's do, we have x is equal to t cubed minus 1. So I'm giving you that t is going from -3 to 3, okay? And I'm just going to have you make t go up by 1. So let's go -3, -2, -1, 0, 1, 2, 3. Don't worry about those last couple of rows. They don't matter. Okay? And then we're just going to crunch these things out. So we have x, we have y is equal to 5t plus 1. So we're going to work out these two equations. So let's just do 2 points and then I'll give you the rest. Okay? So let's do x. Let's do -3 cubed minus 1. That's -27 minus 1, so that's -28. Okay, let's do -2 cubed minus 1. That's -8 minus 1, so that's -9. Okay, all right, and then I'm just going to have you fill in the rest. -2, -1, 0, 7, 26, just to save time. I don't want to bog down and doing arithmetic over and over again. Okay, next thing you do is you do the y value. So the y value is going to be 5 times t plus 1. So if you start with t as -3, you'll have -15 plus 1, or -14. And then 5 times -2 plus 1, that's -10 plus 1, so that's -9. And then go ahead and I'll just have you fill out the rest. Okay? Okay, so just be sure that you know how to do that by hand, okay, without a calculator. You could also put this in your calculator, which we'll do in a minute here anyway, and that'll give you those values, okay? All right, everybody got that? And know what I'm doing? Okay? All right? You'll find Chapter 10 to be a little simpler than what we just got through doing. It's a nice way to end the semester in Calc 2 for students. Okay, I'm going to go to the next page, and let's go ahead and just plot these points. Now, I went ahead, I think I put this, did I put this table on your handout? I don't know if I did, but it doesn't matter. You can just go ahead and plot these points. And remember, we have to kind of do these in order, so this would be your first point. So we'll just estimate this too. I mean, this is kind of, I should have given you guys a lot better graph on this than I did. But let's do, let's just kind of estimate this. This first one is -28, -14. So just pretend that it's down here somewhere, okay? And just maybe label that -28, -14, okay? Then I think maybe the other ones except the first and last are going to match. Okay, second point is going to be -9, -9. Okay, and then the third point is, and again, what you're doing is you're looking at these right here. You're not looking at the parameter t. The parameter t gives you the order this goes in. Okay, then we have -2, -4. Okay, then the fourth point is -1, 1. And then the fifth point is 0, 6. And then the sixth point is 7, 11. So it'll be up there somewhere. And then the last point, just pretend like the graph goes out, way out here and up 16, like that, okay? All right, so those are your points. And then what you need to do is just kind of connect this into a curve, kind of like this. And then the other thing you got to do on this is put your positive orientation. This was point number 1. That's point number 2. So just put these arrows kind of here and there to show the direction that it's going in. Again, we call that the positive orientation of the parametric curve. Okay, like that. Okay, so when you plot that, just don't forget to do that in order and then do that like that. Okay? All right, everybody with me? Okay. All right. Okay, let's write down these two equations and let's eliminate the parameter. And this will help you see what kind of curve this is if you don't know what it is. So let's see, we had x equals t to the third minus 1, and we had y equals 5t plus 1. So let's try this. Pick an equation and solve for t. Which one to you is easier to solve for? Y. Probably the second one, right, okay? So generally, you want to just pick the easier one and solve it. So you can do this in your head. So if you do that, you're going to have y minus 1 equals 5t. Okay, then you can divide both sides by 5. So you get t, you basically get t is equal to y minus 1 over 5. Now, what do you do with that t? You plug it into the other equation. Okay, right. So you're just going to plug that in there. Okay, and see what your goal is to get an equation with just x and y and not a t. That's why we call it eliminating the parameter. So we're going to have x equals t cubed minus 1, where t is y minus 1 over 5. And then just do whatever basic simplification you can. In this case, I'll just write this as y minus 1 to the third. 5 to the third is 125. Okay, like that. Okay. And then I can subtract 1 from both sides. I could also multiply both sides by 25. You know, now that I think of this, it may have been easier to do this problem the other way. But let's go ahead and get rid of the 125. Okay, so if I do that, that's going to be 125x. Okay, that's going to cross that out, leaving that's equal to y minus 1 to the third, and then you got to distribute that like that, and then you would have that. And that's okay, actually. I think it's probably better if I would have done this the other way. So I'm going to go back and do this the other way. It doesn't really matter which way, because technically you should be able to get the same thing anyway. If you isolated both sides, I'm going to do one more thing on this. I'm going to move this over here to get 125x plus 125 equals y minus 1 to the third power. Okay, now I'm going to factor out a 125. Okay, like this. And then what I'm going to do is do the cube root of both sides. Okay, simplify. I'm going to go back and show you that the other way would have been easier. I didn't even think of that. So I'm going to go through and cube root both sides. And let's see, when I do that, I'll have cube root of 125 is 5. Then I'll have cube root of x plus 1 is equal to y minus 1, like that. Okay, now I'm just going to add 1 to both sides. You always try to solve these things for y. So you end up getting, if you add 1 to both sides, you would end up getting this plus 1 is equal to y, okay? And that's where you would start. Well, stop, I mean, okay? All right, let me show you what happens if I did it the other way. You don't have to write this down, but let me just show you this. So if you had x equals t cubed minus 1, if you solved this for t, you would have x plus 1 equals t to the third. Then if you did a cube root of both sides, you would have cube root of x plus 1 equals t. Okay? Now I'm going to plug this in the other equation. I'll show you it's a lot easier. So the other equation was y equals 5 times t plus 1. Okay? Plug that in, and you're going to notice you're going to get exactly the same answer. So sometimes it's easier one way than the other. Okay, it doesn't matter ultimately which way you do that, but sometimes one way will work a little quicker than the other. Okay, so that was a lot easier, wasn't it? Okay, all right, so that's the idea. So what you have is, what kind of function is this that you maybe learned in college algebra? Well, what it is, it's a cube root function. So it has the structure of a cube root function. That's the idea. Okay. So once you go through and eliminate the parameter, you can pretty well tell what that function is. Okay, so that really, like if you're in college algebra, you know what that x plus 1 does, how that shifts stuff? Left 1, that's kind of like a left 1. And how about that plus 1? That's like an up 1, okay? So if you went back and looked at your graph, this thing got a cube root function. This is kind of the key point right there. That went left 1, up 1 like that. Okay, that's kind of the transformations you usually talk about in college algebra. Okay? Okay, any questions about that? Okay, everybody doing okay? Okay. All right, the good news is everybody passed the gateway test. Every single person did, so that's awesome. Okay? I knew you could do it. All right. So let's go through a couple more of these. And this time I'm pretty well done with the graphing. So let's go through and let's just eliminate the curve and identify the curve. And then I want to do a little bit more with eliminating the parameter to show you different things can happen. Okay, what I would do on this one is still kind of the same thing. I would go through and pick an equation and solve for t. What I'm going to do this time is let's do the second equation and let's solve this one for t. Okay, so you can just do this in your head. You're going to get y minus 2 is equal to t. Okay, so what you're going to do is you're going to plug that in. This thing right here gets plugged in right there. So just plug that into the other equation. So you're going to have x equals parentheses, then you'll have y minus 2, like that, then plus 1 to the second, like that. So again, you just plug in and then you calculate. So if we do this, we're going to have x equals, that looks like y minus 1 to the second power. Okay? Now that thing right there, you could multiply it out if you want to. There's really no need to do that, but you could FOIL that out, multiply and solve for y if you want to. But one thing I said is if you're quadratic in one variable, did you catch on to what I said a minute ago, what kind of curve that is? That would be like, what if you had y equals x squared? What kind of curve is that? Parabola, right? Even if you have y squared equals x, that's a parabola. This one just opens this way. This one opens this way. Okay, that's the way those things go. You might not have a good background for that. We're going to talk about that in the very last section this semester then. So that would be a parabola. Whoops. on that. And generally what we want to say on this also is go through a little bit more on that. You can just say parabola, but if we plug in the first number, okay, and then plug in the t, so like the first point is going to be like this. Usually we say that it's a parabola from, and then if you plug in that -10, I'm just going to do the first and last point. If we do -10 plus 1 squared, that gives 81. And then if you plug in the -10 into the y, which is t plus 2, that's going to give -8. So that would be your first point like that. So we'd say 81, -8, 2, and then just do the second point. Okay, if you did the second point, if you plug in a 10 for t, you can do this in your head. That would be 10 plus 1 is 11. 11 squared is 121. Then over here, 10 plus 2 is going to be 12, like that. So usually if I want you to describe the curve, say what type it is, and then say where it's going from here to here. I should have said that on the last problem. I just didn't take the time to do that. So that's what I want you to do for describing the curve. Okay? All right. Everything okay? Okay. All right. So that's how you eliminate the parameter. It's going to get a little bit different once we get into sines and cosines and stuff like that. So generally, if you can solve for t, that's the way you eliminate that parameter. Solve one of them for t, plug it into the other. But you can't always solve for t. That's the problem. So that's what we're going to look at next. Okay, any questions so far? Okay, all right. So let's see. Now we get into some trig functions here. So let's go through and let's eliminate the parameter. I'm going to do a couple of these on the calculator too. So what you have to do with this is, let's go ahead and let's write down these two equations. We have x, which gives the x values, 1 minus sine squared s. This time s is the parameter, just for something different. And y is equal to the cosine of s. Okay, like this. So one of the things that you do a lot on these problems with trig, particularly sines and cosines, is you want to take advantage of this identity. Now, since s is our parameter, I'm going to write this familiar identity as sine squared s plus cosine squared s equals 1. So a lot of times it's real handy to do that, okay? So you can't really solve this for s without making this problem into a big mess. I mean, you could do the inverse cosine of both sides on this one to solve for s, but you want to kind of avoid that. So what I'm going to do is I'm going to take advantage of this. See, I already got a sine squared in there. I would like this to be a cosine squared, and then maybe this identity will be helpful. So how do I what can I do to this equation right here to make the cosine become cosine squared? You can square both sides, right? Okay, you're allowed to square both sides of an equation, so you can go ahead and do that, okay? So that's what we have then. And then what we're going to do on this is we basically have this now. So we have x is equal to 1 minus sine squared s, and now we have y squared is equal to cosine squared s like this, okay? Now, what I want you to see on this is, do you know what that is? Isn't that just the cosine squared? Yeah, because you got this identity right here that you learned in trig. If you rearrange that, you get cosine squared s is equal to 1 minus sine squared s. So you have to look for things a lot of times when you eliminate the parameter. Okay, a lot of times on sines and cosines, that's what you do. Okay, a lot of times. So that means that this second equation is really going to become the first equation is going to become this. We're just going to change that to x equals cosine squared s, okay? Now, those two things are equal, right? So what you would do is you really would be doing a substitution, okay? This thing right here is x, so you can replace that cosine with what it's equal to, it's x, so you would end up getting the equation y squared equals x, okay? Now that identity, I thought we use that because I saw a sine squared and I saw a cosine squared. The key that kind of clued me to that was 1 minus sine squared. Okay, so that would be the elimination of that. Okay, what kind of curve is that, by the way? It's going to show up a lot. Remember I said quadratic in only one variable. If you're quadratic in both, then it can be either a hyperbola, an ellipse. It can be one of those type of things. Okay, so if it's quadratic in one, it's a parabola. So the other thing we need to do is we need to go ahead and find like the first point, s equals pi, and then we need to find the second point when s is equal to 2 pi. So I'm just taking the interval and I'm running through everything on this. So let's find the first point and the last point. So let's see. The first point, we have x is equal to 1 minus sine of pi squared. That's going to give s, or x. And then we also have y is equal to cosine of pi. So I'm just plugging into these two equations for pi. And I'm going to work out the details. Okay, so this is going to be 1 minus, let's see, the sine of pi is 0, so that's 0 squared, so that's 1. Cosine of pi is, what, negative 1, so that gives you your first point, which is 1, negative 1. Okay, like that. Okay, then go ahead and do s equals pi, 2 pi. So we do the same thing. We do x equals 1 minus sine of 2 pi squared. And then y is equal to the cosine of s, so we're going to do cosine of 2 pi like that, and just see what we get. Okay, so let's see, sine of 2 pi is 0, so that's 1 minus 0 squared, or 1. And then cosine of 2 pi is 1, so that means we get a point 1, 1 like that. Okay, so if you're going to describe your curve then, the way you want to say this is you just say it's a parabola. And then you just say from the first point, 1, negative 1, to 1, 1. Okay, that's its positive orientation, is going from that point to that point like that. Okay? All right, let's go through just since I showed you how to get your calculator set up, let's go ahead and put this in. So is there any questions about how I eliminated the parameter or anything else I did? Okay, with trig functions, it's a little different. You can't just solve something for the parameter. Okay, let me put this in the calculator. If you want to do this with me, let's see what we get then. So the way you would set this up is in your parametric mode, you would have to go, for x, you would go 1 minus, then you'd have to have the sine of t. That whole thing would have to be in parentheses like that. So it's like 1 minus parentheses sine t squared. And then when you go to y of t, you just put in cosine, the original. The original was cosine of t like that. Okay, you want to be in radian mode, so you want to be sure you double check that you're in radian mode on this. And then for the window, just do exactly what I gave you in the problem. So I gave you that we're going to go from pi to 2 pi. Now I'm going to go ahead and go, and this is my orientation of t, so I just put in exactly what that is, so that's pi, like that. T max is going to be 2 pi, so I put that in. You can increment by whatever you want to. I'm going to say something small like 0.05, but that's your call. The smaller you do your t-step, the more points it generates. That's the idea. Okay, and let's see. We had a 0.11, and we had a 0.1 negative 1. So let's do something like this. Okay, looks like we have y squared equals x. Let's go 0 to, I don't know, maybe 0 to 5 or something like that. Sometimes you have to do a little guesswork on this. And then for y minimum, let's do negative 5 to 5 and just see what we get. Okay, we can adjust if we have to. Okay, so that would be a pretty good viewing window. And then if you've got those two things in, you should see a parabola, and the parabola basically should be opening around the x-axis. That would be the idea. Come on, get over there. Okay, so I'll put my window over there, and let's see. Okay, let's see what we get here. Okay, there we go. Parabola like that. Now notice the parabola stopped. Why did it stop? Because the t only went to 2 pi. So if we made that parameter get larger and larger, it would create more and more of that curve like that. So that's the idea. Okay. All right. So that's how you do that on a calculator. All right. Any questions about that one? Okay. Let's go ahead and do this one. Go ahead.
So on this one, because it's a trig function, if you increase the parameters, it doesn't change the graph. But on one that was not a trig function, would that be like changing the bounds of the?
Yeah, it would. And actually, all of these problems I've done, even like this one, if I made t expand, because this is a cubic function that goes on forever.
So just extend it.
Yeah, so you got to just extend that. Generally, what we're doing with parameterization is defining it in some interval. Right. You know, just sort of to get the basic pattern on that.
But for this one, so it wouldn't matter how big you made your t because the range of the trig functions is from -1 to 1.
Yeah. Now the starting of pi, this thing can get bigger and bigger because what it's doing is, remember, this is generating x values. Those things are going to change or aren't going to change much because if you're doing y is equal to cosine s, well, you're within some particular boundary defined by that cosine. Same thing with 1 minus sine squared. Okay, so that's the idea. All right, let's do one more of these, and this one's a little bit different. So again, what you do a lot of times is if you see sines and cosines, oftentimes this comes in handy. Okay, so let me show you how this goes. All right, so what I'm going to do on this one is two things. First thing is, I would like to turn that cosine into a cosine squared. So how do you do that? You can square both sides of the equation. And I'm going to do the same thing with the sine. Okay, like this. So let's just square both sides of this equation. Now, some of this stuff just takes a little bit of time and practice. All we're doing is just kind of getting our feet wet here a little bit. So this one is going to become x squared. 3 squared is 9, so that's 9 cosine squared t. This one is y squared equals 9 sine squared t, like that. Okay? Now what we're going to do is we're going to do this. We're going to just say x squared plus y squared, like that. And when we do that, that's going to give us these two things. This is what x squared is. This is what y squared is right there. So I'm just adding those two together. The reason for that is knowledge of conic sections primarily. So this right here is going to be 9 cosine squared t. This is going to be 9 sine squared t. And then we're just going to put this together then like this. Okay, so let's see what we have. You can factor a 9 out. And then you would have cosine squared t plus 9 sine squared t, like that. Whoops, not a 9. Take the 9 out, okay? All right, well, what do you get? Okay, of course, this thing right here is 1, right? That's your fundamental identity. So what you get is 9 times 1, so you get 9. So that means your equation is x squared plus y squared is equal to 9. Okay, do you guys recognize what that is from like college algebra, your background? That's a circle with what radius? 3, right? It has a radius of 3, because what you learned in college algebra, and you may not remember much about this because it's been a while, is this would have a center of 0, 0, and would have a radius would be, so if r squared is equal to 9, that means that r is equal to 3. Okay, that's the standard form of a circle when the center is at 0, is at 0, 0, like that. So partially I knew that. Okay, when you start getting a little bit more experience with parametric equations, these things have a structure. If you have like a cosine t and a b sine t, that's the approach that you're going to take. And since these two numbers were 3s, okay, that's why it's a circle. If one of them was a 3 and one of them was a 6, it wouldn't be that. It'd be an ellipse. So it would change slightly on that. Okay, so that's the idea. Okay, let's do this last, I think the last page on here, just to wrap it up. All we're going to do is just do a little bit with this section. So let's see. This one says find a parametric equation for the following circle and give the interval for the parametric values. So we have a circle centered at the origin with radius 12 generated clockwise, okay, like this. Now this one, I think what I'm giving you is, this is just something I'm going to sort of show you how to do. What you have, you might want to write this down. If you have a circle, I probably should have wrote this down, but go ahead and write this down. If you have a circle with center 0, 0, and a radius, the radius we call r, well, here's what you use. When you parameterize a circle, you go like this. You let x equal like r cosine t, and you let y be r sine t. That's just like the problem I just did, where you had 3 cosine t, 3 sine t. So what we're going to do now is in parametric form, we're going to generate a circle that's at the origin, meaning 0, 0, and then it has a radius of 12. Okay, so what we're going to do is we're going to let x be the radius 12, which is given, cosine t, and then you're also going to let y be 12 sine t, like that. Okay, so that's the parameters that you're going to use on this then. Now there's one other thing that I need to pay attention to on this, and that basically is we have an initial point of 0, 12. Okay, so we have that then. Okay, now what you can do on this one is, this one has a center of 0, 12 like this. Okay, so this is the center of the circle. This is the radius like this. So then it's saying that you're generating this clockwise. Okay, so what we're going to do, what's going to happen on this is your circle's going to go around like this. So the positive orientation is going to go like this. Okay, so you can actually do this problem backwards too if you want to. It doesn't really make that much difference on this. But let's go ahead and let's just generate this circle based on this, and then I'll show you kind of what we get here. So you're going to do this the same way. The one thing I want to show you on this, though, is notice that if we do, this right here is pi over 2. That angle is pi over 2, right? So notice what happens if we do the cosine of pi over 2. Okay, well, the cosine of pi over 2 is equal to 0. Okay, so that's going to work in this. Okay, so you have that. And then if you have the sine of pi over 2, the sine of pi over 2 is 1. Okay, so that would generate that same point like this. So these are generating that point, right? Okay, you can tell that 12 cosine t, if t is pi over 2, is generating that point. Okay, so what we're going to do is kind of like the last problem. We're going to just square both sides. Okay, like this. Okay, then when I do this, I'm going to have x to the second is equal to 144 cosine squared t. Okay, then I'm going to square both sides here. I'm going to get y squared equals 144 sine squared t, like that. Okay. So what we're going to go ahead and do then is just the same thing. On this, you know it's a circle. That's why we say x squared plus y squared, okay? Because the general form of a circle is x squared plus y squared equals r squared. That's how I know to do that then, because they're telling us to make a circle. So let's see. Let's just do x is going to be this. Y is going to be this. So then you just go ahead and write down what you have. So you have 144 cosine squared t plus 144 sine squared t, okay? Then what's a good thing to do from here, probably? Factor out the 144, right? Okay, so we can do that. All right. And then, of course, this is 1. That's your fundamental identity. So you get 144 times 1, or you get 144. Okay? So that means your equation is going to be x squared plus y squared is equal to 144, like that. That's a circle that has a radius of 2, like that. Okay, now the next thing I wanted to kind of show you on this is you can kind of go through and verify the points. Right here, you would expect this point to be 12, 0, right? Okay, that's what you'd expect on a circle like that. So notice if you have x is equal to 12 cosine of 0, I mean, that's our first parameter like that. Does that work and give you the x value of 12, okay? Yeah, because that's 12 times 1. So that gives 12 like that, okay? So you're doing that, okay? Then what you have is if you had y is equal to 12 sine of 0, would that work out okay, giving you 0? Okay, so that's going to give 12 times 0, so that's going to give 0 like that, okay? So that should be the equation of that circle on this, okay? So what you're doing is you're taking these parameters. In general, you can kind of use these parameters if you're dealing with a circle like that, okay? And then that's the idea. That's your equation. It's got a radius of 12. You can tell by looking at that, okay? All right, does that make sense? Okay. All right, now that's the first point right there. So that's what we'd end up having. The other thing that you got to do on this, though, is if you did this way, now you would have to kind of generate this like this. There's more than one way to do this. You're really going from pi over 2. You would be parameterizing from pi over 2 like that. Then you would be going 0, negative pi over 2, and then negative pi that way like that. So you would be starting with pi over 2. Then you would be going downwards with numbers like this. You would be going down like to 0, and then negative pi over 2, and then negative pi, and then negative 3 pi over 2. So you could make your parameters start at pi over 2, and then going clockwise like that. That's one way to do the problem, okay? All right, does that make sense to everybody, okay? All right, okay. So the next thing I'm going to do is just one thing with derivatives. I want you to know how to do derivatives. This is a pretty simple thing to do. So if you're dealing with things that are in parametric form, you can also do the derivative for parametric curves, and that gives you slopes of tangent lines and so forth. So what you want to do on this is if you have two parameters, like you got x as a function of t and y as a function of the parameter t, so if the two functions are differentiable on a to b, then the slope of the tangent line is defined to be this, okay? So what you do is you just do, if you're going to find the derivative of y, you just do this, okay? You do dy over dt. That's how you get the derivative of y, okay? And that is going to be g prime of t, okay? That's what that is, okay? Then if you want to find the derivative of x, well, that function is f prime of t. Well, what you do on that is you just do dx with respect to t, okay? And then you do this ratio on this, okay? So it's kind of like a chain rule on this one. So what we're going to do on this is we're going to find the slope of the line, and that's all I'm going to do on that is just do the slope. So this is already in a parameterized form. So what we want to do is let's start by writing down we have x is 4 minus 3t. So what you're going to do is you're going to do the derivative of x with respect to t. So we just do dx over dt. Okay, well, the derivative of this function with respect to t is what? It's negative 3, right? Okay, we're doing that with respect to t, so that gives that value right there. Okay, then we write down y is equal to negative 2 plus 6t. So what is dy over dt? That's 6, okay, like that. That's it. So now if you want to find dy over dx, which is what you're doing, then you would just do this, okay? You would just do dy over dt. That comes first, that's your numerator, and then dx over dt like that. It's easy to remember that because the dt's kind of cancel, right? So you end up with dy over dx. So what you would have then is dy was 6, dx over dt is negative 3, so you would get a slope of negative 2. That would be the idea, okay? Now let's do one other thing with this problem because I want to show you that's how you can do that. If it's in a parameterized form, you don't need to eliminate the parameter and take it back to a function of y and x, but let's go ahead and eliminate the parameter on this one also. So I want to show you you'd get the same answer. Okay, so if you want to eliminate the parameter on this, you just pick either function and set it for and solve it for t. I'm going to take this parameter for y, and I'm going to go ahead and I'm just going to solve that for t. So if I do that, I would move the t the other side to get y plus 2 equals 6t. Then I can divide by 6. So I end up getting on this, I get y is equal to y plus 2 over 6. Okay, now that thing is going to plug in to the t of the other equation. Okay, and you could have done this backwards also. So what I'm going to do now is take the first equation, x equals 4 minus 3t, then I'm just going to plug in what t is in this other equation. So in that other equation, it's y plus 2 over 6 like that. Okay, then when I do this, okay, notice that the 3 over 6 reduces to a half. So you got x is equal to 4 minus, and then that would be parentheses y plus 2 over 2 like that. Now I'm going to solve this for y. Okay, so what I'm going to do is I'm just going to multiply both sides by 2 right now. Okay, so I'm going to take this whole side by 2 to get rid of that fraction. And I'm going to multiply this side by 2 like that. Okay, if I do this, I'm going to have 2x here. That's going to be 4 times 2 or 8. And then this is going to be parentheses y plus 2. So just some basic algebra solving for y. It probably would have been easier to do this the other way, but it doesn't really matter. So this is 2x equals 8 minus y minus 2. So that's 2x equals 6 minus y. Now what I'm going to do is just kind of rearrange this. I'm just going to move the y to this side, and I'm going to move the x to this side to get y equals negative 2x plus 6. Okay? Now, the reason I wanted to do this is, okay, what is the derivative of this function? What is dy over dx in this problem? Same answer, okay? So the thing is, a lot of times if you're parameterized, sometimes it's just as easy to find the derivative this way instead of having to eliminate the parameter and do it that way. But you'll get the same answer. So that's the idea. So all you really do is just do dy over dt, dx over dt, and form that ratio. That's it. Okay? All right. So that's all I'm going to show you in that section. Any question about what I just did?
So